Okay, so we are familiar with a positive integer as exponent. For example, 2 to the third, we know this 3 means 3 copies. So which means, and also exponent means multiplication. So we're going to multiply the base number 2 3 times. 1, 2, 3. So we take 3 copies of 2, multiply 3 copies of 2. Okay, so we got 8. But what if I give you a negative exponent, say 2 to negative 3? Well, unfortunately, we cannot use that idea, say, okay, this exponent means how many copies. So it doesn't make sense to say, let's multiply negative 3 copies. How do we do negative 3 copies, right? 3 copies, it's 1, 2, 3, but negative 3 copies, we cannot do that, okay? And a common mistake was, I think some of the students are confusing this question with like 2 times a negative something. By the way, 2 times, even with the positive exponents, I know a common mistake was some students thought 2 to the third means 2 times 3, that they got 6, but be careful, they're not the same thing. When 3 is raised, it's not going to be the same as 2 times 3. It's different. So that's why mathematicians created this symbol to raise it, to distinguish from 2 times 3. So the meaning is different. Okay. So the same thing here. 2 raised to negative 3, it's not going to be equal to 2 times negative 3 because negative 3 is raised. So what is the meaning of a negative exponent? So that's something you need to remember. So I'm going to, again, it's like a definition. So I'm going to start with 2 to negative 1. Now, a negative exponent means reciprocal. So I have a negative exponent. Let me write it down here. So what does negative integer as an exponent means? It means reciprocal of the positive exponent. So what this means is you can get rid of negative sign. It just means 2 to the first, but with the minus means you have to take the reciprocal of that. So this means the reciprocal of 2 to the first. And this concept of reciprocal, we use it when we solve the equations. I don't know if you remember, like if I gave you 2/3 x equals 5, how do you get x by itself? You will have to multiply by the reciprocal 2/3, which is 3/2, right? So the reciprocal pretty much means you flip that fraction. That's called reciprocal. So when we try to find reciprocal of 2 to the first, or just 2 here, you will flip 2. Well, how do we flip 2? 2 is not a fraction. We can write 2 as 2 over 1. After we flip 2 over 1, switch, 2 and 1, you're going to get 1/2. So what is the answer for 2 to negative first? It just means 1/2. It's going to change this to like a fraction, 1/2. So be careful, 2 to negative 1 is not equal to negative 2. I get this every semester. Not many students, but I always have a couple of students who forgot the definition of negative exponent. So when you raise it, it's going to make you do the flip. So flip the whatever the base is. Okay. So that's the new definition. And you're not going to get, see, we still get a positive. 1/2 is still positive. So we take the reciprocal of 2. 2 is positive. We start with the positive. And when we raise to negative 1, we still get a positive number. We didn't get a negative. Okay. All right. So that's the definition. That is something you need to memorize. Okay. Keep this in mind. And that's the only thing new. Everything else is we're gonna use the formulas we used previously. We learned those formulas before, but we need to combine those formulas with this new definition. All right, so I'm gonna, before we look at the homework assignments, giving you examples, I'm gonna try to give you another one before we do that. So what I just did is 2 to negative 1. What does that mean? It means 1 with reciprocal of 2. So you take the flip 2. But what if we want to do 2 to negative 3? So like I said, this -3, negative, what does this negative mean? It means you flip. What do you flip? It's like you get rid of that. So you get rid of that minus sign. You flip whatever you have left after you get rid of negative sign. So you flip a 2 to the third. So let me put that back, the minus sign back. So this minus sign in the exponent means you will, first you can drop the minus sign in the exponent. You will get 2 to the third, which is 8. And then you're going to flip your answer. You will get 1 over 2 to the third, which is 1/8. Okay. So you will have to, when you have a negative exponent, usually you got to do 2 steps. Which 2 steps? You can do 2 to the third to get 8. And then step 2, this because there is a minus, you got to flip 8, which is 8 over 1 to 1 over 8. Okay. There is another way to do it. Because what I did is I always did 2 to the third and then deal with the minus in the exponent, which means flip. You could actually flip first and then do 3 copies later. So this -3 means, this 3 still means 3 copies, but that minus sign just gives you extra operation that you have to do. It's whatever you get, you got to flip it. Okay. But you could have flipped it first. So the other way to do 2 to -3, I could just do 2 to flip 2 first, because this negative tells me to flip. So I'm going to flip 2, which gives me 1/2. After I get 1/2, I'm going to deal with that 3 copies. So I take 3 copies of 1/2. That gives me 1/2 times 1/2 times 1/2. Or you can use the formula we have, raise 1 to the third, raise 2 to the third. And that gives me straight cross, 1 times 1 times 1, which is still 1. 2 times 2 times 2, that gives me 8. So the same answer, okay? Probably the first way is easier because it's easier to do 2 to the third, because it's 8, and then flip 8. So the difference you can see in these 2 solutions. In solution 1, I first step 1, I got 3 copies of 2. And step 2, I did the flip. I flipped the answer. But in second solution, I flipped it first. Second solution, so as you can see, I first flip 2, I got 1/2, and then I do 3. I do 3 copies. So it depends on which one you want to do first. Sometimes it's easier to like in this case, I would do solution 1 because it's easier to do 2 to the third and then just flip the answer. But if they give you fraction, you might, I guess it doesn't make a difference. If I give you 2/3 raised to -3, so it probably doesn't make a difference anymore. So I could do 3 copies first, so which means I take 2/3 and do 3 copies. That gives me, we can use the formula to do it, or you can use the definition. Either way, I'm going to do definition here because we have to expand it anyway. All right, so 3 copies of 2/3. And I multiply straight across. 2 times 2 times 2, it's 8. 3 times 3 times 3, 27. Now, after I get this answer, I need to, this minus sign tells me I got to flip my answer. So the final answer will be 27/8. Okay. That's one way to do it. Solution 1. Now, solution 2 will be, I can deal with this minus negative exponent first. So first I'm going to flip 2/3, flip it up the numerator and denominator. I get 3/2. And I'll deal with this 3 copies. So I take 3 copies of 3/2. So that's going to give me 3/2 times 3/2 times 3/2 and multiply straight across. 3 times 3 times 3, 27. 2 times 2 times 2, 8. So look, it's exactly the same answer. Okay, so that negative exponent just gives you extra step that you have to do. Okay. So these are the numbers. If we change, for example, I can change this 2 to a variable x. Let's put, if I have x here, x to -1. That means you got to flip x. Okay, so x is just like, 2 means 2/1. When you, after you flip it, you get a 1/2. So x, the same, means x over 1, very similar to 2. And you can always put a 1 underneath. And after you flip it, you get a 1 over x. Okay, so it's very similar, the same idea, same definition. Now, similarly, what if I change this 2 right here to x? So we're going to do x to negative, raised to a negative third. That means, what does this mean? I can do 3 copies first. So that means I'm going to take x raised to the third. But after I get this, I need to flip it, because x to the third means x to the third over 1. After I flip it, I will get a 1 over, I actually get a 1 over x to the third. So let me erase the process, erase the process here, erase this. Okay, so what is x to negative 3 raised to negative 3? It's actually equal to 1 over x to the third. Okay, so you will flip it to the bottom. The other way to do it is x to negative 3. You can go ahead and put over 1 at the very beginning. And, okay, so there's a negative exponent. In order to get rid of negative, we got to do the flip, right? So how do we flip? Flip whatever that is to the bottom. So you're going to flip that to the bottom. By the way, that 1 is still here. But notice 1 times anything will be the other thing, right? So that's why you still end up with x to the third. And the top, after you flip this to the bottom, there's nothing. Nothing means 1, because was an invisible 1 here. We didn't have to put 1 there because we have something. But after you flip this to the bottom, you do have to put the 1 back. Okay, but the bottom 1, you can omit it now because I have something in the denominator now. So that's the other way to look at it. Okay, so let me summarize this right here. So in general, if you have x to something, to a negative x, we know x to the n. If n is positive, we know what this means. It just means x times dot dot dot, this many copies. N copies. So if your n is 3, you will have 3 copies. If n is 5, you're going to have 5 copies. And we also talked about, last Thursday, we also talked about x raised to 0, which means it's equal to 1. So today we have negative n. What does this mean? It means 1 over x to the n. Okay, so it means you flip x to the n. All right, so that's the new definition for today. So maybe I can send you a quick question. See, I actually found out, finally, I found out how to use the whiteboard to share a whiteboard with you. So let me try that. Let's do this and that. So actually everybody can draw here. So I'm going to write a question here. Okay. So if just let's try to do, how about we start with the easy one. 3 over 4 raised to negative 1. The first question. And the second question, we can still use 3 over 4, 3/4, but this time we're going to do negative second. Okay. All right, so you can do it on your scratch paper, and then maybe, I don't know if anybody can write on your computer, and maybe you can volunteer to try to write your answer up here. You can, if you have a touch screen computer, you can just choose a pen up there. You can see a pen up there, and you can choose the pen. And you can use your, I guess, fingers. Oh, who is doing that?
It's Katie.
Katie, okay. If you don't have touch screen, then you will have to use a mouse, okay? Oh, I was actually just gonna you know, if you don't, not everybody has to write here. Okay, so I was just gonna give it a try, and also I was going to ask someone or any volunteer to do it. Okay, so Katie, you are doing it, so you can go ahead and write your answer there. Other student, if you wanted to type in the, if you wanted to show you your answer, you can put in the chat box, or if you want to write here, that's fine. Okay. Let's see. All right, so what Katie had is correct. And who did put the other answer there, 3/4? 4/3, I mean. Emily? Okay, all right. All right, so this is something probably I will use more often next week when I'm doing reviews. So instead of me giving you or explaining every single question, I want to give you a little bit time to work out the problems yourself to see if you can do it. So, and I may ask some of you to show your work here, see how to do step by step, and I may be able to tell you, you know, if you get stuck somewhere, I can tell you how to continue. So this is sort of like in the classroom and ask someone to come up to the board and to show you how to do the question. Okay, all right. So, Katie, do you want to explain your answer? Your answers are correct, but can you explain how you got the first answer, say 4/3?
What I did is just flip the. Sorry, a second, I got distracted.
That's okay. Yeah, that's right. That's right. You just flip the fraction 3/4, right?
Yes.
Okay, what about the second one?
I did the same thing, just flipped it, and then you square the top and the bottom.
Okay, so you did the flip first and then square it. Okay. All right, that's correct. There's another way you could square it and flip. So either way, okay. So for the first one, Paula, okay, is the final answer always positive? Not always. If the number given is negative, yeah, that's a very good question. I'm gonna give you another example in a second. Okay, so if you are given a positive, Amanda, do you have do you have a question? I think your mic is on. Okay, so in the first case, -1 just means you gotta flip 3 and 4, because 1 means one copy, right? So you're gonna do one copy of the step. It's not gonna change anything. So 3/4 and you flip, you get 4/3. Okay, and the second one, what Katie did was she flipped it first. So 3/4, after you flip it, you get 4/3, like we get here. But and we still have to do 2 copies of 4/3. That gives us 16/9. Okay, you could do the square first. For example, I can do square of 3/4 to get 9/16, and then I flip it. Okay, so it's up to you which you want to do first. It doesn't, I don't think it makes a difference if it's a fraction. Okay. All right. So now let's go to, okay. Yeah, Molly, I can see that. Yeah, sometimes we make mistakes. We think we can reduce this, right? But actually we can't. Well, go back to Paula's question. So do we always get a positive? I did say, you know, we start with the positive, and then after we flip it, we still get a positive. But when do we get a negative? We do get negative sometimes. That's when we have a negative. So what if I have a negative 3/4 here? Well, how do we flip a negative number? Do we need to do anything with that sign? Okay, so let's kind of explain this. Now that uses a little bit of idea. If you get confused after I flip, how do I flip negative 3/4? And go back to the definition. Well, not really definition, the division of sign numbers. So -3/4. There are a couple of ways to look at it. You could do -3 divided by 4, or you could do 3 divided by -4. Because a negative divided by positive, that will give you a negative number. And positive divided by negative, that also gives a negative number. So in fact, -3/4 has other two equivalent forms. So all these three fractions are actually equal. So the minus sign, look, you could have put it on the top, or you could have put it on the bottom. But you cannot distribute it, okay? So this minus sign doesn't mean you have negative on the top and the bottom. That's different, because negative divided by negative will give you a positive. It's not going to give you negative anymore. So whenever you want to move this minus sign, you can move it to the top, you can move it to the bottom, but you cannot have it both in the numerator and denominator. Okay, so maybe this will help you understand. Let me erase this. Okay. So that will help you understand how to do the flipping. So if I give you this and then minus sign confuses you, like when I flip, what do I do with this minus sign? Do I need to flip the minus sign? Well, don't look at that one. Look at this one. Okay, so when I flip the top and the bottom, I'm going to flip 4 to the top and flip -3 to the bottom. And a positive divided by negative still gives me a negative, right? Okay, or you can say, well, can I use the other form? Yeah, sure. If you use that one, so you start with the 3 over -4, and after you flip it, then you're going to get -4 in the numerator, 3 in the denominator, and which is still -4/3, because negative divided by positive is still going to be a negative. So what does this tell us? It tells us when you flip a negative number, see, like you have a minus here, the minus sign will still stay. You don't have to do anything. When you do the flipping, you don't have to do anything to the minus sign, okay? And why? Because that's the explanation here. So with the minus sign, either on the top or on the bottom, after you flip it, that minus sign will still, if it's on the top, it's going to be flipped to the bottom, but it's still there. And if it's on the bottom, when you flip it, it's going to get on the top and, well, still there. So that still makes the final answer a negative, okay? So maybe later when you do that, and you don't have to worry, just remember whenever you flip a negative number, you don't have to do anything to the negative sign. It just stays. All you have to do is to flip the fraction 3 and 4. Okay, so if I put a minus there, yes, you'll get a minus, negative. But the second case, it's actually going to make a difference. So, well, I guess I don't think I will give you, let's see. Yeah, I don't think I will give you any of the negative. So that's the only thing you need to remember, okay? So it's possible to get negatives. And other questions? So if you understand all of these, let me switch back to my PowerPoint. Okay. So, all right, so let's go back to these. Now we can start to do I think you should be able to do like the first 2 problems in your homework assignments, week 9 homework assignments under section 5.6, but I'm going to give you some examples to try to help you do your homework. So when you do your homework, when you go home do your homework problems, if you ever have trouble, you can go back to watch our class video again, because I usually try to give you a very similar example. So for example, in the homework, this is the one in the homework assignment under section 5.6, -1/2 to -3, right? So I'm going to give you an example for that, which is going to be, let me change it -1/2 to -1/3. And I'm going to change that -3 to, maybe I can change it to negative, let's do -5. Maybe it's going to be a little bit similar. Okay, all right. So I guess this is kind of similar to the one we just did, right? But with a minus sign here. So we could do, you can do 2 steps. So first step, maybe we will do the flipping. See, like I said, you could either do flipping or do 5 copies. It's up to you. But if it's -1/3, I would do flipping first. Why is that? Because if I do the flipping, I will be able to get rid of the fraction, okay? Previously, I gave you, was that 3 over 4? When you do flip, you will get a 4 over 3. It's still going to be a fraction. But when you have 1/3, after you flip it, you get 3 over 1, which becomes the integer 3, right? So that's why I'm going to choose to, for this specific example, I am going to choose to do the flipping first. And remember, the negative sign, when you flip it, it's not gonna disappear. So you will still have negative, and then you will have 3 over 1, which is -3. Okay. So what I just did was I did this minus sign. This minus sign, this operation tells me I gotta flip whatever in the parentheses. So this is what I just flipped. Minus sign stays as my previous explanation. 1/3 after I flip, I get a 3. Okay. And next, we're gonna do -3 to the 5. 5 copies of -3. -3, -3, -3, -3, and -3. Okay, so that goes back to the topic we did before the first exam. So you're gonna have to do multiplication of sign numbers. Okay, so we're gonna have 9 here, 9 here. Negative times negative is positive. Okay, so 9 times 9 is 81. 81 times -3. Positive times negative is -243. So that would be the final answer. Okay, any question? Okay, now, but if you did the other way, you did 5 copies of -1/3 and then try to flip it later, it's gonna be the same. Okay. All right. Now let's look at the second question. We're gonna have. I think this one is actually easier than the one we just did. So in the homework, it's -3 to -2, right? So I'm gonna change this. Give you a similar example. Example 2. And I can do -4 raised to, well, maybe, I'm sorry, let me change it to -5 raised to -4. Okay. Okay, so this time I'm gonna do 4 copies first. Okay, by the way, the 4 copies, it's gonna be 4 copies of everything in the parentheses. Be careful, parentheses do make a difference here. So I'm going to do -5 raised to the 4th. Okay, so which means, and later I have to do a flip. Okay, so I'm going to do -5 times -5 times -5 times -5 4 times. And negative times negative is positive 25. Negative times negative is positive 25. And 25 times 25 is 655. Okay, when you take the exam, I won't give you big numbers like this. Okay. So you will have -5 raised to the 4th. So far I only did this, 4 copies of -5. That gave me 625. But this minus right here in the exponent tells me to flip whatever I got. So I should get 1 over 625. Okay. If you did flip first, you should still get the same answer. So if you did a -5 to flip -5, that's going to get you -1 over 5. And when you do 4 copies of -1 over 5, so -1 over 5, -1 over 5, -1 over 5, you get a 1 over 25 times 1 over 25, which gives you 1 over 625. Okay. All right. That's the second example. The rest of the problems on page 1, we have 6 problems left on page 1. And for the rest of them, you are going to use the formulas we learned previously. So first, I'm going to actually ask you to review these 5 formulas. So let me send a link to you because this time I do want everybody to try to participate. So I'm going to send a link to you. in the chat. If you cannot access the link, don't send the link. Maybe you can write on the whiteboard. I will also share the whiteboard with you, but in a second. So let me. So those 5 formulas that 2, 3, 4, 5. Okay. It's called a laws of exponents. Okay, share, copy. Okay, so when you open the link, you don't see any questions. I give you just 5 spaces. You can type in your answer, but I'm gonna put the questions up here. Okay, so let's see. So these are the formulas we learned before. Okay, so just I think it was just the last week. Okay, let me, I guess I can erase all of these. Oops. Oh, I can just do that. Okay, so the first question is going to be x to the m times x to the n. What you need to do is to put the answer in that link. How do you type an exponent? You can use this little thing. Where is it? On the keyboard, it's like to the 6 on top of the number 6. So you can use that to, for example, if you want to type x to the mth, you just type x and then type this little sign there for m. Okay, so write your answer under question 1. Under question 2, it's this one. Question 3. And question 4. And question 5. Oops, not x, it should be. Okay. And these 5 formulas are very important. When you take the second exam, you need to know all these 5 formulas. And also when you take the final, you also need to know these. Oh yeah. What is, maybe it's because, okay, so let me try to see how I fix this. What just happened? Okay. What, see, this is something I haven't figured out yet. I think somehow I zoomed in. Whoops. All right, let me just switch back to my PowerPoint. Okay, so let me put it right here again. So x to the m times x to the n is the first one, the second one, and the third one. Fourth one. And Number 5. Oh, Lord, I can't breathe. Oh, is that Amanda? Oh. Are you all right? Are you okay? Okay, so I saw Molly and Katie already submitted, and Emily. Okay. Okay. Okay, well, actually, very good. So it looks like Katie, Molly, Emily, and Abby. You guys have all the 5 questions right. Your answers are all correct. That's good. Okay. Okay. So I'm gonna wait a little bit. Any more submissions? Okay, got one more, Melissa. Okay. Actually, Melissa, for number 4, you can describe your answer in exponents. Okay. Let's see. All right. I don't know if other students are still working on it. If you just know, say, the answer for 1 or 2 of them, you can also submit just for the ones you know. Okay. Anybody else is going to submit? Okay. Let's see who. All right. Okay, so Paula, you did number 3, number 4, and number 1. Okay. All right. So your number 3, number 4 are correct, but number 1 is incorrect. All right. So I think I'm gonna look at go over these formulas here. Okay. So although I give you all the symbols, when you memorize these formulas, you can use words to describe the formulas yourself. Okay, so that way, I think it's better than like using symbols. The form most of the time in mathematics or physics, chemistry, when you see those formulas, they're written in symbols. The reason we're doing that is because it looks easy. Okay, when you do the problems or when you try to describe the formula, if you just say x to the m times x to the n equals x to something, it's not really very easy to understand. So probably when we memorize it, I would describe it. I would use sentences instead of symbols. Okay, symbols, formulas in symbols, they look beautiful, they look neat, clean, and simple, but it doesn't mean it's easy to apply. Okay, so when I look at the first question, it's like multiplying 2 exponents. Okay, and the answer, most of the students submitted who did get right. Paula, actually, you had m times m. Actually, it should be m plus n. Okay, the answer for the second one will be m times n. So when I describe the formula to myself, I would be when we multiply, so the product, when we multiply 2 exponents, you actually are going to keep the base and add the exponents. So you would say add the exponents. But when you have exponent of exponent, we call it a power of power. So when you see 2 powers beside each other, we call it a power of power. And the first one is more like a product of powers. So you have a product multiplication of powers. So in the first exam, I tested you with all those words, like what does product mean? It means multiplication. Quotient means division, right? So this actually means product of powers. How do you do product of powers? You keep the base. Let me write it down. Keep the base. In this case, the base is x. So we keep the base x. We add the exponents. So we add m and n. But if you have power, you will keep the base but multiply the exponents. So it's multiplication. Okay, I'll give you two specific example to explain that. So in the first case, it's like doing x squared times x to the third. In the second case, it's like x squared to the third. So the first one, the answer should be x to the fifth. Why? Because you have 2 copies here, 3 copies there. Together, if you count them, it's 1, 2, 3, 4, 5, right? It's pretty much 2 plus 3. That gives you 5. 2 plus 3. That gives you. But in the second case, when you have power, 2 powers together, it doesn't mean you have 2 copies of x and 3 copies of x. It means what? You have 3 copies of whatever inside the parentheses, everything in the parentheses, which is Paula answered in one of the classes many times. So you will have 3 copies of x squared, okay? So it doesn't mean 3 copies of x anymore. Look, that's the main difference here. So when you have x to the third, it just means 3 copies of x. But when you have x squared to the third, it means you have x squared, and x squared. It's not x anymore. Okay, so that when you have 3 copies of x squared, that gives you count how many together, 2 plus 2 plus 2, that gives you x to the 6. And which can be done by multiplication, because this pretty much means I have three 2's. How much is 3 2's? No, 3 times 2, that's 6, right? So what 2 times 3, that's 6. So that's the biggest difference. Again, they are always easily confused when we add them. So let me highlight. When do we add the exponents? When do we multiply? So the tip I gave in class was, if you have 2 powers right beside each other, you're gonna multiply them. But if they're not, then you add them, okay? All right, number 3, number 4, everybody, I think everybody got it right. So it's like you distribute the exponent to them. So you're gonna raise x. Again, that's the definition of parentheses. So if you have parentheses, that means you gotta raise everything to the exponent. With multiplication, you could raise each of them to that exponent. And with division, you could also raise each of them to that division. But I do want to bring this up again. If it's plus, suppose I have x plus y to the n, or x minus y to the n, you cannot raise each of them to that. So it's not equal to x to the n plus or minus y to the n. Be careful. All the formulas that we have only involves multiplication or division. There's no formula for plus or minus, okay? All right, now the last one, so for division, the exponent will be x to the m minus n, okay? Why? Because if I ask you to divide x to the fifth by, maybe I should just get a new page here. So if I ask you to divide x to the fifth by x to the second, how many will be left when you do division? Because the top means you have 5 copies and the bottom we have 2 copies. And division, we can cross out the common factor. So we cross out 2 copies from both top and the bottom because they have 2 in common. So how many are left? 3 left. Why? Because top we got 5 copies, and after you cross out 2 of them, then you're gonna have 3 left. So the formula is the top exponent minus the bottom exponent, 5 minus 2. Okay, so go back to look at this formula. That's why when we have division, we take the top exponent minus the bottom, so m minus n, okay? All right, so these are the 5 formulas we talked about, I think it was last week and maybe the week before that. Okay, so today we introduced something new to you, which is the negative exponent. So let me actually ask you to do some of the questions we did previously. So I am going to give you another page. Okay. Okay, so again, the next few questions are also going to be review questions. You will have these on the second exam, but the topic of today, we are also going to use the similar idea. So that's why, okay, it's good to practice it. So to make sure you know how to do these. So the first one I will ask you to do is going to be, okay, negative. Okay, so I'm going to do negative 5x to the second times negative 6x to the, let's do fifth. Okay, so the first one, I'm going to send you a link in the second. Hold on a second. So you can put the answer there. So we're going to do, let me see how many questions. One, oh, 2, 3, 4. The first one is multiplication. Second one is division. Three and 4. Okay, so the link is in the chat. The second question, 24 x to 6 divided by negative 8 x to the first. Well, okay, so try these 4 questions. Oh, yeah, I forgot to share, sorry. Okay. All right.
My link isn't working. Can I just type the answers?
Yes, yeah, sure. Okay, so Emily and Melissa, your answers are all correct. Okay, and Molly, your answer is also correct. All of your answers correct. Paula, looks like your first three are right. The final one, I think you made a mistake in the number 4, that exponent of y. And Katie, your answer is also correct. Okay. Braden, let's see. Okay, good. Braden, all your answers are also correct. Okay, so these are the type of questions you will get when you take the second exam. So they can all be solved by using the formulas that you just did. Okay. I don't know, are there anybody planning to still working on the problems? Again, if you just did 1 or 2 of them, you can also submit. Okay, so let's take a look at these 4 questions. Now, the first one, we could just, we did the same type of questions on your week, I think it was last week, week 8. So we're going to multiply, because it's all multiplication. We are able to switch x squared and -6. So we can multiply -5, -6 to get 30. X squared times x to the 5th. That's exactly our first formula. Let me see right here. Okay, so when we have product of exponents, and we can add the exponents, keep the base and add the exponents. So we're gonna get x to the 2 plus 5. You don't have to write this down, write this step. You can go ahead and just get 30x to the 7th. I want to write this down to show how we got 7, because we added 2 and 5. Okay, similarly, we divide, and 24 by -8, we get -3. And we divide then because the bottom has exponent 1. So we're going to do x to 6 minus 1, which gives us -3x to the 5th. Okay. In the third one, because it's multiplication, and the fourth one, multiplication in the base. Oh, actually, the final one, I meant to give you a division, but I guess, okay. So the third one, you can distribute the exponent to raise each of them to that exponent. So you're gonna get 2 to the 3rd, which is 8, and to the 3rd. The final one, because I had multiplication there, so you're gonna raise x squared to the square and to the 2nd, and y 5th to the 2nd. Paula, I think what mistake you made was you thought it was 5 squared, but actually it's multiply them, not doing 5 squared. Okay, so when we multiply 2 times 2, that gives us, let me write it down. So we're doing 2 times 2 and y 5 times 2. So it's not going to be 5 squared. When you have power, you're going to get the power times the power. So that gives us x to the 4th, y to the 10th. Okay. All right. Now, let's put the new thing we learned today, the negative exponent, in here. Okay, so I'm going to change these questions. By the way, the last one, actually, I meant to give you division. If it was division, you're just going to have division here instead of multiplication, division and division. Okay, but everything can be done the exact same way. Now, what if I have, so in the first question, negative 5x squared times negative 6 x to the 5th, I'm going to change those exponents from positive to negative. So I'm going to change this to negative 2 and negative 5. Let me do. And I want to, wait, am I going to be able to, whoops, I can't, okay. Let me see if I can erase those lines here. Okay, so let me just make small changes on these questions we just did. Oops. Okay, so let me change this from positive 2 to negative 2, positive 5 to negative 5. So although the exponents have changed from positive to negative, the way we do it is going to be exactly the same. Okay, but if you say, well, at the beginning of the class, you said negative x to negative 2 means flip, right? So should we go ahead and do that? No, don't do that until in the final step. Okay, previously, because the question that I gave you, it was just one number, say, okay, negative 3 to negative 2, specific numbers. You don't really have to apply the formula. You just go ahead and do the definition, negative 3 squared and the flip. But right here, we actually have multiplications that we have to do. Because in that one, you didn't have to multiply it with anything. But right now, we do have multiplications. We can multiply negative 5 and negative 6 to get 30. That's exactly the same as what just did. But when we multiply these two, it's not going to be positive 2 and positive 5, right? But what was the formula? The formula said add the exponents. So let me write it down here. Add the exponents. So that's why we added 2 and 5 to get 7, right? But now, even if they're negative, you're still going to use the same formula. Add the exponents. But not 2 and 5 anymore. It's negative 2 plus negative 5. So that's what we're going to be adding. Negative 2 plus negative 5. That gives us a negative 7. Okay, so as you can see, I didn't really have to change much. I just have to we had a negative 2, negative 5. I just changed, I put a minus in front of 2. I put a minus in front of 5. So instead of adding 2 and a 5 to get 7, I get negative 2 plus negative 5, which is negative 7. Okay. After you finish all the multiplication, this step usually can be done by using the formulas, the laws. So adding exponents or subtracting exponents. But the final step, we do need to get rid of that negative sign in the exponent. That's when we apply the definition of flipping. Okay, so how do we flip it? I'm going to go ahead and put a minus over 1 so I can see it's actually in the numerator. It's in the top. So now I'm going to flip. So by the way, don't flip everything, okay? Which can be flipped? Only when you have a negative exponent. For example, 30, what is the exponent of 30? Think about it. I mean, it doesn't have anything, right? Actually, it just means 30 to the first. Okay, so if you have 30 to the first is positive. You don't need to flip 30. So 30, you will leave it in the top, in the numerator. But when you have negative 7, that's something you got to flip to the bottom. After you do the flip, the negative will be gone. You will just have x to the 7. Okay. Well, All right, so that's the answer. 30 divided by x to the 7. Previously, we got a 30 times x to the 7, right? With the negative there, you just get a 30 over divided by x to the 7. Okay, so that's the only thing new here. Okay, the definition of negative exponent, which we practiced before. Okay, so now the second question, I can do the same thing. I can change this to negative, both of them to negatives now. So the numbers will still be the same. 24 divided by negative 8, it's negative 3. Well, but when we are dividing here, remember the formula is subtract exponents. That's here, subtract exponents. But again, we're having, so I'm going to put a negative 6 minus negative 1. So be very careful. I would recommend that you write it down, because sometimes when you're trying to do it in your mind, you might mess it up, especially with the subtraction of sign numbers. So what is negative 6 minus negative 1? So it's going to be keep, change, change. So you actually get negative 5, because negative 6 plus 1 is negative 5. Okay. And a common mistake was we always have students who thought, okay, negative 6 minus 7. Negative 6 minus 1 is negative 7. Negative 6 minus 1 is negative 7. Well, I am doing subtraction because you said division, you do subtraction. But they didn't realize that this minus they're having is, is from the negative 1, okay? There is another minus sign between them, because the bottom exponent already has a minus sign there. And in the formula, there's also minus sign there. So you are going to be subtracting negative 1 from negative 6. So this minus sign comes from the problem, but this minus sign comes from the formula. So that's why we have negative 6 minus negative 1. So there will be a minus minus. That we do keep, change, change. That change it to a plus. Okay, so the answer should be negative to the 5th, not negative 7. So this is a common mistake. Okay, so that probably should just write it down. With positive numbers, you don't have to do that. 6 minus 1, you get 5. Nobody's gonna make a mistake. But with the sign numbers, you might make a mistake. Okay. Again, when you get here, we got to flip. Be careful, negative 3, don't flip it. Because I think some students got used to the idea, okay, well, whenever you have a negative, you got to flip. Be careful, when I say negative, it has to be negative exponent. That's when you flip. Negative exponent. Well, negative 3, this minus is not in the exponent. It just means it's a negative number. I don't have a negative 1 here. So negative 3 stays in the numerator. We cannot flip it. But that part right here, there's a negative in the exponent. So we got to flip that to the bottom. After you do the flipping, you're going to get rid of the minus. So you're going to get x to the 5th. Okay, so again, the answer will be, instead of have negative 3 times x to the 5th, we have negative 3 divided by x to the 5th. Okay, now the next question, let me try to do something similar to the homework problem. So the homework is had a negative 1 here. So instead of having positive 1, they had a negative 1 there. Okay, so it's going to be, I'm going to put a negative 1 here. Again, the way you do it is still going to be the same. So you raise 2 to the 3rd. That doesn't change. And raise n to negative 1 to the 3rd. I'm going to put negative 1 here and to the 3rd. And when you have power, you will be multiplying the 2 powers. That gives us a negative 3, because negative times positive is negative. Okay, for the number, it's going to be the same. 2 to the 3rd will still be 8. Okay, now we got to do the flipping to get rid of that negative. So 8 stays, because it means 8 to the 1st, it's positive exponent, but negative 3 is a negative exponent, so we got to flip to the bottom. So I get 8 over and to the 3rd. Okay, so in the final question, it's going to be similar. So if I put a negative 2 here, negative 5 there, so you will have negative here, and negative 2 times, you still raise negative 2 to the 2nd, negative 5 to the 2nd. So when you raise negative 2 to the 2nd, and negative times positive, negative 2 times positive 2, that gives a negative 4. And then -5 times +2, that will give you a -10. Okay, so that final step, I'm going to try to rewrite it. So this final step right here should look like this. Well, it depends on whether it's multiplication or division. So in the homework, it is division. So I'm going to change this to division here. So if it's division, you end up with x to -4 on the top, x to -10 on the bottom. Okay, how do we get rid of negative exponents? We flip. So that means this -4, in order to get rid of negative sign, I got to flip to the bottom. So I get x to the 4th. And this x to -10, I got to flip to the top to get rid of negative. So I get x to the 10th. Okay, so that would be the, I'm sorry, y. I changed that, sorry. Y to the 10th. So that would be the final answer. Okay, all right. So the first step, when you try to do multiplication or division, you're still going to apply this exactly the same formula. Either add exponents, subtract, or multiply exponents. You're still going to do exactly the same form, use the same formulas. The new thing is, okay, when you add exponents, you could have, adding negative numbers or subtracting negative numbers or multiplying negative numbers. And in the final step, usually if you have a negative exponent, you got to flip it to get rid of the minus, okay? Questions? All right. There are 2 more questions there. I didn't give you any practice, but it can be done in a similar way. So if I give you, let's say, 3 to the -5th times 3 to the 2nd. Okay, so before you try to say, okay, this means 1/3 to the 5th. Before you do that, like I said, always do that in your final step, because this has a multiplication that we can do. So I can apply the formula again. Keep the base 3, add the exponents, -2 plus 3. If you can do that in your mind, you can skip this step. So I just get -3. When you get after you finish the multiplication, you got a final answer. That's when you can do the flipping. So you get 3 to the 3rd, which is 27. And this negative exponent tells us to flip 27. We get 1/27. Okay. Now, next question is the division question. So I have, if I do 9 to the following the homework, which is number 20, is that number 22? 24, okay. So I can do a 9 squared divided by 9 to negative, maybe -1. Okay. Well, maybe I can do, well, -1 is fine. So we are going to first apply the formula. Keep the same base, subtract the exponents. So it's going to be 2 minus -1. Okay, so that minus sign comes from the formula. Whenever we do division, we're supposed to subtract exponents. But the second minus sign comes from the exponent in the denominator. Okay, now we can do keep, change, change. You actually end up with 9 to the 3rd, which is 9 times 9 times 9, 81 times 9, 729. Okay. So now I just give you one example for each problem. By the way, I have a typo in homework. I'll show you a little quick here. So the typo was, I will put an updated version. If you already printed that out,